No. Is it tall or short? Yes or no? It's one syllable. But if you want to say, well, it depends, that's 3 syllables. Maybe that's 2 syllables. We always want clarity. We want to know if it's yes or no, edge or cloud. And we've seen the theme of it's in the cloud, is that good, is it better on the edge? But today I want to talk about edge AI's challenges, how we're bringing things to the edge, still keeping in mind that it's very important that AI use the continuum and exist in the cloud and the edge. So I don't think that it's necessarily going to be clear whether the AI should be in the cloud or the edge, but there are some tasks that really deserve and are trying to get to the edge. There are some tasks that need to be in the cloud. But one thing I'm going to focus on is the real examples that we're seeing today, some of the latest examples of people really deploying AI at the edge, doing some amazing things. Through those examples, let's take a look at our agenda here. Welcome, everyone. We'll be looking at these recent innovations and then looking at the architectures that are enabling overcoming some of the very difficult challenges in moving to the edge, because there are many different challenges involved, and some of the platform innovations and things that have to happen to move forward and make edge AI more of a reality so that we'll see more technologies be able to use cloud and the edge. So first, I'd like to talk about how IoT, another word for the edge, is transforming our lives in many different ways. It's used in medical and health to be able to save lives. We're improving the quality of our lives with smart home technologies of various kinds, now starting to implement AI. In agriculture, they're using analytics to be able to better aggregate and compute all the different kinds of sensors that are needed to tell whether fruits and vegetables have problems with them or not, for example. Public safety, of course, we know all about AI being used in safety and security. Productivity, efficiency in factories and industrial manufacturing. Also lowering costs in finance, and protecting the planet. And there are a lot of really, really great examples. One of the reasons why I was so honored that the team invited me to speak here is that we had some great examples that I'm going to be showing. First, the opportunity, and especially focusing on the silicon. At Intel, we focus on silicon solutions that end customers and businesses can take advantage of to gain insights through AI. But diving into a little bit of why we're so focused on some of these problems is overcoming them is not only very valuable for the end customers, but also for the silicon opportunity. What we're noticing, and some of these observations I'd like to share, is over the next few years, we're seeing a growth in the endpoint and edge devices close to where the sensors are. The aggregate growth is about 25 to 30%. Where there's growth in the use of the data center, but one observation from the research that we have shows that the total available market for edge AI silicon at the edge is actually growing larger than in the data center. And I think some of the previous speakers had pointed this as well. So, and Shailesh from the last talk gave another, although his chart was vertical, this is horizontal, but we see the edge on the left, we see the cloud on the right, and moving the AI technology and processing out to the edge means you have to overcome and overcome some of the key challenges, which are latency, providing very fast processing, also bandwidth, also security, trying to be able to keep your data secure by processing it at the edge, not sending it into the cloud, connectivity, and being able to achieve very high performance. Now, it's funny that I think there's been a lot of AI innovation over the last 40 years, perhaps, and computer vision has been reaped the most benefits from a lot of the research. But why has it been only recently that these innovations have really been able to come to market in a really interesting way? And I think it's because of the platforms that are able to bring the performance required, to bring the low latency, and bring the power down, and bring the cost down. All of these factors are coming together, I think, because of the hardware electronics that are the foundation of what all of the software innovation over the last 40 years has been able to provide. So we're going to focus on the edge and first on some really concrete examples. One of the most interesting in the last several weeks, we announced a partnership with Johnson Controls. I don't know how many of you are familiar with this amazing company. We see some of the company buildings there. They're working a lot in retail. And now we're bringing AI in an interesting way, working with them, into looking at shoppers' behavior. Now, a lot of the technology that we've heard about today can be used on a frame-by-frame basis. So if you're doing computer vision and AI on video, you can get track or detect or classify or segment on a frame-by-frame basis. But you can also do a lot of things over multiple frames of video. And what I find is the most amazing innovations in AI are the behavioral tracking, understanding when the camera is showing somebody tying their shoes versus falling down, or when do you call the ambulance or not call the ambulance. You have to be able to do some kind of AI on many different frames on video. So what we're looking at here is an example of working with a company to be able to bring behavior analytics, how customers' behavior in the store, how they're reacting not only with the staff, but how they're reacting with the products, as well as tracking for theft loss and other kinds of things. So very interesting stuff, and you can read about it more on the press releases. On a more serious note, they estimate that about 35,000 elephants will be killed by poachers. And we're all very, very concerned about our species, and especially species of animals that may go extinct. And it's very interesting how recently there's been a product called TrailGuard, working with a company called Resolve, that has brought technology to be able to track poachers before they kill animals. Now, the state of the art was, of course, with audio. You hear the sound of the gun, you're able to then pinpoint where the sound happened, contact the rangers. The rangers, of course, who there's not enough staff to cover the whole sub-Saharan African desert. They can get to where the animal was killed, but that's too late. The animal has died already. If you can use computer vision like this camera device is, Resolve had developed a camera with the help of National Geographic Labs and some funding from Leonardo DiCaprio Foundation to be able to build this camera that could be put out into some trees and then notice whether there's movement. And when there's movement, the power turns on. The camera is able to then take an image. If the image is not of an animal but of a human, then that image can be sent. So then it can shut down. So the whole point is through extreme low power, you can't go out and change the batteries every few days and plug it in like we do with our cell phones every night. You have to be able to make sure these cameras are out there for at least a year on a battery and run with low power and can get the rangers the data so that they can go after the poachers before they're killing the animals. And there's a recent video about it that you can watch, again, if you look for the announcements. But this is a really interesting technology, and they're seeing some success so far, and I think we all look forward to more deployment of AI technology being used for something as great as catching poachers before they can kill. Moving on to another interesting company in China named Wanli. We've been working with two companies, Wanli and Xiaogu, to install AI into doors, and it just makes sense that you want to have access control using AI. Why have to have the key, or why have to memorize the code? That sounds very simple, but it's actually quite complex to be able to have face recognition that's good enough that even twins, one twin would be allowed to come in and the other wouldn't be if twins were able to program their face. So the problem here is that this company wants all new buildings and government buildings and banks and to be using this AI door. They're doing very well in their market in China. And there's technology there from Intel in two different places. There's RealSense, depth sensing, that has the ability to see whether it's a face or a picture, or you're trying to detect for real human skin and not just a photo or even a Hollywood-style mask of a face. And then also a vision processor. And we'll talk more about the hardware that supports this kind of application. But I think this is going to become a little bit more commonplace moving forward. And it's interesting to see these kinds of applications. Now, when you can achieve low power and high performance, then the real test is, can you put the technology into space? There's a company we're working with called Ubotica, a small group out of Ireland, that is working with the European Space Agency. So they're on a consortium of companies that's developing a board with vision processing and other sensors that have been hardened for the kind of radiation that they're getting in space to be able to do computer vision and AI and be able to look at Earth, I think they call it EO, or Earth orbits or Earth images. So to be able to detect anomalies and do computer vision on photos of the Earth, but while orbiting in space. And I think that's the testament to being able to deploy something with very low power. So no, you wouldn't be training your neural network on this hardware. You would be deploying the neural network that had previously been trained in the data center. So finally, I'd like to point out for future applications, we'd worked with this very unique hotel, Sinclair Hotel. It's a traditional hotel in Fort Worth, Texas, Dallas-Fort Worth. And we call it the first all-digital hotel because it had completely transformed with IoT technology to be able to have controls, all of the appliances using power over Ethernet. It's a really interesting example of how you could transform the experience in a hotel using various kinds of IoT technology, which to me is a foundation that can now be able to support AI moving forward into the future. So, of course, with the, you check into your hotel, and if you want the hotel room to recognize you and be able to offer services and various kinds of things, maybe you wave your hand to make a cup of coffee instead of having to fiddle with the coffee maker. All of those things potentially in the future we can do with this kind of all-digital hotel. So now let's dive in a lot deeper into how the technology works. So I'm going to be pointing out something about a processor called the Movidius VPU. So this is our product line at Intel, which powers compute-efficient AI running at the edge. And when we're talking about the edge, we're usually talking about the inferencing. So some of the talks earlier today talked about better use, how we train, how to do better training, how to be annotating, and all of that. Then once you have the neural network trained, you want to be able to deploy it in very low power and still sufficient performance to get the accuracy that you need. So this is our purpose-built architecture that was built from the ground up to handle computer vision kinds of applications of AI inferencing. So we could see it has some image processing because, as we know, you want to connect cameras. You need to be doing all of the camera processing up front, and then programmable processors so you can do human-engineered programmable computer vision applications. But then we have this special block up here on the right that's highlighted there called the Neural Compute Engine. So that was our dedicated ASIC block to be able to provide tops of performance of AI inferencing on deep learning networks for specific camera and server applications running at the edge. So this whole chip is aimed to be running at just a few watts of power. And it could be doing several kinds of analytics. Let's say you have to detect some kind of object, and then you want to be able to classify, is it a car, is it a bicycle, what's the license plate, things like that. So typically you have to run multiple neural networks in a very small amount of power to be able to run some of those applications at the edge, especially if they're cameras in a retail store or in a medical device, handheld medical device, or if it's running in an industrial atmosphere. So we then take these Movidius VPUs and we can put them on boards. And so we have a large program running where we're working with ODMs that are building based on these reference designs for cards, where we can take the energy efficiency of one VPU and make that efficiency a little bit better by scaling over multiple VPUs. So for example, this card, if you run a few neural networks on each chip, then you can run maybe 16 neural networks on a card that has 8 VPUs on them. And these kinds of PCI plug-in cards are being used by companies to build very power-efficient edge servers. So if you have a server on site at a store, you can then keep the data within the store and use the data to achieve some analytics, understand your customer's behavior, and not once have to send the video raw data to a server, because then there's some privacy issues, or people may not want to walk into a store that's going to be sending data to the cloud. So that's one of the ways in which we use these vision accelerator cards, is what we call them. I did want to talk about how the chip technology is accelerating moving forward. I think some of the themes we've heard about today, quantization is very important, because then you can reduce the size of your network. That can enable it to run faster, run with less memory. There are other kinds of ways that companies are now taking advantage of building better hardware. Let's say to take advantage of sparse neural networks, where there's sparsity involved, then you can take advantage of optimizing the compute so that you don't have to do as much compute as you would otherwise do. Various kinds of ways to reduce energy, to reduce power. And of course, if you're reducing power, it's not just directly a power reduction, but it's also limiting the space and reducing cost in the server that you're building. So if you imagine a card that takes a lot less power, then you could build the server with a lot lower cost. So we just disclosed in November a new generation of Intel Movidius VPU, codenamed Keembae. Our vice president got on stage at a press conference. He talked about the fact that this is now a new vision processor coming out this year. It'll be available later in the year, and we've achieved about 10x the AI performance as the previous processor in a similar range of power. So to be able to do 10x what the previous Movidius VPU was able to do. But it's interesting that the customers that we're working with not only need it, but they need more. And so the more AI you can provide within a limited amount of power, with the amount of accuracy that the customer's neural networks need to run, will only fuel these kinds of applications, like in retail stores and in industrial manufacturing and in health and medical and in agriculture. So it's really exciting to see that we're able to bring even more performance for deep neural networks inference at the edge, even in these small chips. So you'll hear more about this later in the year for sure. And but is it really only hardware that can make these innovations happen? No, it's software and the workflow. And so what I wanted to talk a little bit about to round out the talk now is that it starts with people optimizing their neural networks, training the neural network, being able to do exactly with the right accuracy what you need the neural network to do. And there's a lot to do in terms of the optimization. Then it comes to testing it. We've also deployed a technology called IoT Dev Cloud, which enables developers to get a login, send a neural network in a standard framework up to our dev cloud to be able to sample on one or various kinds of Intel hardware, whether it's a CPU or FPGA or our Movidius VPU. You can then go to the dev cloud and test out neural networks. Then you want to deploy it. So you want to see, well, okay, now how much power does it take? What's the accuracy? How can I make it deployable in a reasonable cost on one of these platforms? So we have a software toolkit called OpenVINO for visual inferencing and neural network optimization. That's what VINO stands for, kind of a fun brand name. And it allows you to then deploy the neural network on any one of these platforms. So whether it's the Movidius chip for very low power or a CPU for more general purpose processing, you can then run the deep neural network on different platforms to see, well, what platform works the best for me? And then finally deploy it and experiment with whatever kinds of form factors you need to deploy. So we've created the OpenVINO software toolkit to enable this kind of workflow to go from testing and prototyping your AI to make sure the algorithm is correct, and then to be able to deploy it in an IoT kind of application. But it's not just the tools themselves. You also have to have various vertical market solutions that will help you, overcome certain problems in various vertical markets. One of these areas is industrial environment. And if you have experience in industrial manufacturing, there's a lot of different challenges, different equipment that has different kinds of protocols, the way they talk to each other. Of course, timing, how data ingestion happens and how storage is happening. And being able to have security and near real-time feedback throughout factories or throughout multiple factories. You also need high-performance AI and analytics. So we'd like to bring a lot of the AI and analytics technology that we have in platforms like Movidius into an industrial environment, but it's not as easy as saying, oh yeah, just build it into the robot or just build it into the machine vision PC. We have to have software tool flows that then enable overcoming some of these problems. So earlier we announced something called Edge Insight software, which now developers that Intel is working with are using to be able to overcome some of the problems specifically for the industrial workplace, whether you need time series or what kind of data is being brought in, what kind of images you're operating on, the kind of AI that you need to implement, and be able to operate this in a way that works at a sort of software, at a more higher level software. So we've created not only the hardware, but also the software tool flow, and then for certain applications like industrial, to be able to, we've deployed Edge Insight software to enable overcoming some of these very particular problems for industrial manufacturing. And then, of course, you can't really do much without an ecosystem of partners. And at Intel, what that means is software partners, ISVs, some of you that are here that I recognize are working with us on making some of the technology work. Some of the chips that we build go into reference designs like the Vision Accelerator card I mentioned, to be able to deploy them with these partners that can build the cards tailor-made because they have manufacturing capability to be able to build the cards for certain customers. So it takes this really huge ecosystem to make it happen. And when I say make it happen, I'm really talking about how do you get sufficient accuracy, sufficient performance, low enough power, and low enough cost, which are a lot of real challenges to overcome to deploy real systems at the edge. And with our OpenVINO software toolkit and working with these customers that are now using that toolkit and partners, we've been able to help overcome those challenges. So overall, what we're aiming at is more compute efficient edge AI to be able to solve more of these problems in the future. We're working tirelessly because, of course, the more you solve these problems and offer better AI performance, the more developers need. And it's just a vicious cycle. So thank you very much. That was my talk for today. Appreciate it. We have time for a few questions here?
Sure, you do. 7 minutes.
7 minutes. Everyone's a cloud engineer. Okay, we have some. First hand was back there. Yes. We have groups at Intel that work on communications and networking. We're working very, very closely with them on making sure our reference designs work with those comms chips, other memory chips throughout the company. So if you want to talk to us later, we can share with you some of the information about those reference designs. No, it's... Oh, you're looking at SoC level. Yeah, board level. Yeah, those kinds of things. That's a start.
Do you have any benchmark information that you can sort of cite to verbally comparing the Movius with NVIDIA?
It's interesting you say that because when we disclosed the new Kimbei VPU, our Gen 3 Movidius VPU in November, we did give some benchmark information. I didn't have that in this talk, but that information is public. You can go to our website. I can show you later, and you can watch the video and look at those slides. In terms of power efficiency, in terms of compute efficiency, in terms of performance, inferences per second per millimeter square of silicon, we fare very well.
Next question.
Last question.
You can hear you.
You're talking about Habana. Yes, we announced recently that we had acquired Habana. How do we position it? Well, it's been acquired very recently. They're working on the cloud, so their devices are for training in the cloud, and you can come talk to us and we'll tell you more about them. But thanks for mentioning that. All right, thank you very much. Oh, one more last question. Sorry, one more last question.
Yeah, I have a similar questions as the previous one, but I also have a follow-on question for this Movidius. So it sounds like the Movidius are more focused on the edge computing side for the industrial and the consumer side, right? Do you have any plan for the automotive?
That's interesting you asked. I didn't mention automotive because the Movidius and our Edge AI portfolio is specifically for those kinds of edge industrial, retail, security applications. Mobileye is a group within Intel that's working 100% focused on automotive. They have a long history of working on software and hardware integration for pedestrian detection and some of those things. And they're bringing them to market very quickly. So the Mobileye group within Intel is focused on just that problem, automotive.
But their business model is quite different from the traditional, like the Movidius and the CPU side, right? They are more closed business models compared to yours.
We have different products in a company, so.
So I mean, basically, I just want to ask if Intel has any edge computing, the solutions for automotive, but also like open business models,
Yeah, well,
different from the mobile eyes.
Well, automotive contains a lot of different use cases. For example, like I said, the computer vision for automotive autonomous driving. There's also computer vision used for in-cabin, where we have other solutions. So we can talk after about what those are.
Okay, thank you.
Thanks so much. Appreciate
Thank you.
it. Oh,
This is your computer. Thank you so much.
I'll come back for my plug.